Good afternoon, my YouTube viewers. It is Crystal here, and what I'm going to do in this video is I'm going to give you a code review for a simple linear regression, including weights and biases, with the Boston house prices dataset. Okay, so basically, I apologize for the video that I made yesterday because I wanted to show you my bronze medal, or the email that I had with my bronze medal, and it showed the email with the bronze medal, but it didn't show any of the code, so I'm sorry about that. I decided to go ahead and keep the video up because I'm not monetized, and since I'm not monetized, I wasn't going to get anything out of it. So the video's up, but I have left a link to the Jupyter Notebook with Kaggle, so you can get the Jupyter Notebook with Kaggle and follow my words with the Jupyter Notebook with Kaggle. But on this particular code review, you're going to get the code because I don't have an email to show you. And this is on the Boston house price dataset. Boston house price dataset used to be on sklearn, but it's been taken off sklearn because it's not very politically correct. So if you want to use the Boston house price dataset, then what you have to do is you have to find it on a GitHub CSV file. You have to find it as a CSV file, and most of the time it's on GitHub. So I've written this program with the Boston house price dataset on Google Colab, which is a free online Jupyter Notebook hosted by Google. And so Google Colab is a great platform to use to write code in Python. The only problem is that it does not have a very good undo function. So you have to be very careful not to accidentally overwrite or delete code. If you do accidentally overwrite or delete code, you can go to the save history and there's a possibility that you can get it back, but it's not a guarantee. So what we're going to do is we're going to go through this program that I've written. First thing we're going to do is we're going to import pandas as PD. We're going to read the CSV file in from pandas and convert it into a data frame, and then we're going to set the columns up. So you've got you know what the columns are, and then the DF is your data frame. So you can see the data frame right there. So what we're going to do is we're going to set our X and our Y variables. Your Y is DF MEDV, and then your X is your DFLSTAT. So the MEDV is like medium price or medium salary or something like that, but it's a medium price of some sort. And LSTAT, I'm not sure exactly what LSTAT is, but that's just the column of data that they wanted used for X, because I'm doing an interview question. And then you want to convert X to a data frame because some of the models won't work if X is not a data frame, so you convert X to a data frame, making it two-dimensional. Okay, so you could standardize X, but you could standardize and normalize X, but we're not going to do that. I tried the code with standardization and with normalization and without, and then I just decided not to use standardization or normalization. But you can practice. If you want to practice with standardization, or if you want to practice with normalization, you can do that. And find out what your RMSE, that's root mean squared error, is going to be. So we're going to use train test split from sklearn to split the data set into training and validation sets. And then we also print off the shapes of the training and validation sets. Sorry, I'm coming down with a cold. I'm sorry about that. So the next thing we're going to do is we're going to import Seaborn as SNS, and what that does is that allows you to statistically view your data. So the data is going to be data frame DF, X is going to be LSTAT, and Y is going to be MEDV. So you can see what LSTAT and MEDV are, and you can see it on a scatter plot. Now we're going to use the model, and the model that we're going to use is sklearn linear regression. This is perhaps one of the easiest models that you can use. So from sklearn.linear model import linear regression, linreg equals linear regression dot fit x train y train, ypred equals linreg dot predict y val. So you can see the ypred, which is the predictions. Now we're going to calculate the RMSE. So the first thing we do is we calculate the MSE, and then we calculate the RMSE, and then we have a root mean squared error of 5.789. We compare the actual values against the predicted values, so you can see what they look like. Now we're going to plot the actual values against the regression line, and you can see that what it looks like. One thing I think I might do though, because the next one we're going to do is going to be stats models. So we're going to do simple linear regression with stats models. And the thing that I will say about stats models is that the simple linear regression doesn't work as well. It gives you a higher RMSE. So we're going to import statsmodels.api as SM. Y equals df MEDV, X equals df LSTAT. And then what we're going to do is we're going to just normalize it to make every value be between 0 and 1. And then we're going to create the model with model equals sm.ols, y train, x train, results equals model.fit, print results summary. So you can print the result summary here. We're going to find your ypred equals results.predict xval, ypred equals ypred.revel, ypred. And then we check our RMSE, which is 16, so the RMSE is a lot more. And then we plot with Matplotlib, we plot our actual values against our predicted values, which is the regression line. And you can see it doesn't look very good. But what I want to do is, okay, I'm going to run it again so you can see what the actual values against the predicted values are using stat models. And so the actual values and the predicted values are a lot different. It's not very good, but that's just the way it worked with stat models. And I tried several different ways to redo it. So what we can do here is we can, I think with the max and x over x max, I think that was the best way that I could get it to work. But what you can do is you can experiment yourself and see if you can improve the RMSE by normalize it, standardize it, or don't normalize or standardize. But that was the best score that I could get. But if you want to experiment with it yourself, you can. And now we're going to use NumPy linear regression with weights and biases. So we're going to import NumPy as MP. And so we're going to make a class called Simple Linear Regression. And in this class of Simple Linear Regression, we've got an init function, a fit function, and a predict function. So the init function just initializes your weights and biases. So your weight is your slope coefficient, and your bias is your intercept. And your fit is x mean equals np mean x, y mean equals np mean y. So you're going to get the mean of x and y, and you're going to calculate the slope. Numerator equals np dot sum x minus x mean equal times y minus y mean. Denominator equals np dot sum x minus x mean to the square root of 2. Self dot weight equals numerator over denominator, and self dot bias equals y mean minus self weight times x mean. And so that's the fit function is what trains the data into the model. And now we're going to make a prediction. So if self-weight is none or self-bias is none, raise the exception. Model has not been trained yet. Use fit method first. And then it says return self.weight times x plus self.bias. And then you get the example usage. So if name equals main, you set your random number up, your seed up for your random number, then x equals df MEDV, x, the y equals df MEDV, x equals df LSTAT. And then we set it up for normalization, which all the values are between 0 and 1. So max x equals np max x, x equals x over max x. And then we split the data set up into training and validation sets. We convert y-train, x-train, y-val, x-val into NumPy arrays. Then you create the simple linear regression model. Or model equals simple linear regression, model.fit, x-train, y-train. Now we make our predictions. Y-pred equals model.predict x-val, y-pred rabble, it says print y-pred rabble. So there you've got your y-pred. And then we check our RMSE, which is 5.789, which was the same as sklearn. And we check our predicted values against our actual values, and you can see what that looks like. And we can do this. We can create another data frame. And you can compare the actual values against the predicted values on the data frame. So now what we do is we do Jack's linear regression, which is pretty much the same as NumPy linear regression. And the reason why is because the Jack's has been written very closely on the NumPy API. The only difference is that the random numbers are different, and Jack's arrays are immutable. And so that's the difference. But you've got your class simple linear regression, you've got your init function, which is the same, you've got your fixed function, which is the same, and then you've got your predicted function, which is the same. The only difference is that you're using JNP instead of NP. So now we have our example usage. So we set our key up. Key equals jacks.random.prng key 42. And then so you've got your x-train, y-train, x-val, y-val are converted into Jack's arrays. It won't work if it's not converted into a Jack's array. And then so you've got model equals simple linear regression, model.fit, x-train, y-train. Now we make our predictions. Y-pred equals model.predict x-val, print y-pred.ravel. So you've got your YPRED, and then now we've got our RMSC of 5.789, which was the same as the NumPy simple linear regression and the sklearn simple linear regression. And then what we've done is we use matplotlib to plot the actual values against the predicted values. And then another thing that we can do we'll rerun that. And then so you can see the actual values against the predicted values. Now what we're going to do is we're going to use SciPy. SciPy is a scientific library with Python, and SciPy also has the capability to perform simple linear regression. It has a function that will do that. So from scipy.stats, import linregress. So you got Y-train, X-train, Y-train, XVal, YVal are going to be converted to NumPy arrays. It won't work if you don't convert it to a NumPy array. Res equals linregress, X-train, Y-train, print res intercept standard deviation. So you've got your res intercept is 34.83. Your res intercept standard deviation is 0.63. And then what we're going to do is we're going to plot the actual values against the fitted line. That's your predicted values, your regression line. And so we're going to make predictions on YPRED equals res.intercept plus res.slope times xval and YPRED. So you can see what that is. And then we've got our RMSC, which is 5.789, which is the same as what you got with sklearn. And now what we're going to do is we're going to run it one more time. So you can see the data frame where you can look at the actual values against the predicted values to compare them. And that's it. That's how you perform simple linear regression on the Boston house price data set. And we've done it using sklearn linear regression. We've done it using stats models linear regression. We've done it using NumPy linear regression. We've done it using JAX linear regression. And we've done it using SciPy linear regression. So we've done this 5 different ways, libraries that you can do it. So it's in your best interest to learn how to do this and all the different ways, because you don't know, you might be asked this question on an interview, so you'll need to learn how to perform simple linear regression. So I'm going to go ahead and conclude my video because I've been talking for close to 19 minutes about simple linear regression, and I've done a code review. So I'd like to apologize for my most previous video where it didn't show the code, but you got the Kaggle notebook, and with the Kaggle notebook you can call up the Kaggle notebook and look at the code and follow along with the video if you want to, because again, I'm not being monetized, so I'm not getting anything financial out of these videos. So when I get monetized, maybe I'll go back and change it all, but until I get monetized, I'm not going to. So I'd like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you very much again for watching my video. I look forward to making more videos for you in the future.